Hi and welcome to this solving session related to annuity and deferred annuity. Let's begin with exercise number 1. In this exercise, I want to withdraw $1,000 at each of the following periods, and I want you to determine the minimum deposit that you should make now at 10% in order to be able to withdraw these amounts. Note that you'll have to make another deposit at year 7 of the value of $500. Now I need you to just read this statement. With the minimum deposit, your balance at the end of year 10 would be 0. What do I mean by the statement is that the amount that you're gonna deposit is going to be equal to the amount that you're gonna withdraw. Whatever you're gonna put in your bank account, you will be earning interest on it. That will allow you later to make the following withdrawal. So this is the idea that you should keep in mind. Whatever you're gonna pay here and here is going to be equivalent to whatever you're gonna withdraw later from your bank account. Can you withdraw any amount if you didn't do a deposit, if you have nothing in your bank account? So it's the same. So if I want to calculate P, then I will consider each one of these as a single value in the future and get its present and then add the summation. Or we will use the method of annuity. So I will say in one step that this is an annuity and I get its present worth in using one step using the equation. But you need to mind here that this cash flow diagram has 3 parts. I didn't have a straight annuity. Whenever I have here at this period a missing arrow, so I cannot say that from year 1 till year 10 this is one annuity. No, since there's something missing here, so I will have to split this part alone, this part alone. And here this is a payment. So if I consider this part, this is an ordinary annuity. If I want to get its present, P equals A into P, knowing AI, which is 10%, and N, which is from period 6 till period 0. So N equals to 6. Or we said also that we can count the arrows. 1, 2, 3, 4, 5, 6. So we have 6 amounts to be withdrawn. So N equals to 6 regarding this annuity. Now here, this is a single amount in the future, but it's being paid. So if I want to get its present value, I will have to put the sign in front of it as a negative, a minus sign, because this is something paid. And I will say that the present value of this future taking place at year 7, P equals F into P, knowing Fi 7. We still have this part here. You can notice that this is an annuity, okay? But this annuity doesn't begin at year 1. So it is an ordinary annuity, however, it is deferred in the future. Now, how do we deal with deferred annuity? As we said in the lecture, you'll have to look. Where is the first payment taking place? It is at year 8. So where is the present value of this annuity? It is the period before. Okay, so this is the present value of this annuity. It occurs at year 7. So for how many years is this annuity deferred? It is deferred by 7 years. So this is J. So when I get the present value here, this is P at J, and J equals to 7. So I get the present here of this annuity at period 7. Then the final answer, I will consider that this is a future value far away from my present by 7 periods. And I get the present value of each part alone, and then we add the final answer. So that's why I split this cash flow diagram into 3. This part related to a deferred annuity, this is a future value, and this is an ordinary annuity. So the answer will look like this. Here I want to show you again two methods for solution. Method 1 is the method that I explained on the cash flow diagram. So the present value is the present value of the ordinary annuity, P equals A into P knowing A I6 minus this 500, which is a future value, so P equals to F into P knowing F 10.7 because it's located at year 7, plus this is the deferred annuity, so it's A into P knowing A I N. Now N for this deferred annuity, or here in the rule we used N minus J, it is 3 because the last payment was at year 7 and the present value of this deferred annuity is located at period 7, so 10 minus 7 equals to 3. Now this is the present at period 7, so this is P7. Now this all will become a future value at which you'll have to return to the present, so as if I'm saying P equals F, this is F, into P knowing F, I7, because this annuity is deferred 7 periods. Now the final answer will look like this. Now the second method, I proposed this method of solution to show you how do we equate at the future. Okay, here in the question I'm interested in getting the present, but I will equate things at the future and then the future at year 10, the final answer of the future at year 10, I will get its equivalent in the present. So let's go have a look again at the chart to see how will we move things to the future. So here we have this annuity. Now if I want to get the future of this annuity, where will it be located on this timeline? As a rule, you must understand that for any annuity, the present value lies the period before the first arrow. So with respect to this annuity, where is the present of this annuity? This is the first payment. So the present value of this annuity lies here. Okay, one period before the first payment. And as a rule as well, you must understand that the future of any annuity lies at the last arrow. Okay, so when I want to get the future of this annuity, F equals to A into F knowing A I6. Okay, because the future is here. Okay, and I have 1, 2, 3, 4, 5, and 6 payments. Always double check if you are confused what is N. Count the number of arrows that you have. So I got the future here at 6. But I'm asking, or I was proposing to get the future at year 10. So how far is this future at year 6 to the future at year 10? And moreover, if I'm standing here and I got the final answer of this annuity, the future at year 6, what would this represent with respect to the point to year 10 in the future? Because this is my final destination, whatever I will get here will be considered as if it is a present and I'm getting its equivalence in the future. Okay, so I got the future at 6. In order to get the future at 10, I will be saying F equals to P because all of this will be considered as P. So F at 10 equals to the resultant that I will be getting at year 6, F equals P into F knowing P, I N. How far is this period from this period? It's 4. Now, what will be the future value of this $500? This is a present value found at year 7, and I need to get its equivalence in the future. So F equals to P into F knowing P, I N. How many periods is it far away? 1, 2, 3 periods. Now, with respect to this annuity, I want to get its future. Now, the future of this annuity lies at the last arrow, which is my final destination, so it's fine. Okay, so F of this annuity equals F equals A into F knowing AIN. Now, how many periods is it there? You cannot say that from 8 to 10 we have 2 periods. No, because the present value of the annuity is at period 7. Okay, this is the starting point of this annuity. So 10 minus 7 is 3. And to double check, we count the number of arrows. 1, 2, 3. So n equals to 3. So you see, F for the ordinary annuity is 1000 and F knowing A 10, 6. And this is the future at year 6. So it will become the present because I want to shift it from year 6 till year 10. So when I shift it to the future again, F equals to P, all of this will become P into F knowing P 10, 4. Why 4? Because it's the difference between 10 and 6. This is the 500 far away by 3 periods. And this is the annuity and where you see that n equals to 3. Now I got the final future value at year 10. And in the question, I want you to calculate P. So you just say that this is the future at 10. Its equivalence in the present, P. I'm following this equation. P equals F into P knowing FIN. So P equals F. This is the final answer of F into P knowing F 10% and 10 period because the distance between the amount found at year 10 till year 0 is far away by 10 periods. So you can see that I got the same answer. Why did I presented this second method? Just to realize that you are working on a timeline and you can get the equivalence of any amount from the present to the future. And if you use several methods, these methods can give you the same answer. So there's no one single method for solution. Now let's look at exercise number 2. What is the value of C that makes these two annual cash flows equivalent at 10%? So you can again equate at the present or equate at the future in order to get the missing amount of C. With respect to this cash flow diagram, all the amounts are known. With respect to this one, we have an annuity, okay? But this annuity is deferred. Why deferred? Because here I have a missing payment, so I cannot say that this is a straight annuity. So because we have a missing arrow here, I can say that this annuity is deferred. It didn't begin at period 1. Now, if I want to equate using the present, when I'm getting the present value of this cash flow diagram, what do you notice? You notice that we have an amount of $100 at P0. Remember what did we say during the lecture? If I want to get the present value of this amount, P equals F into P knowing FIN. Now, since this amount is standing at year 0 already, so n equals to 0, so the value will be 100 multiplied by 1. So that's why when I'm getting the present value of this cash flow diagram, this amount will be just added. So you will say P equals 100 plus. Then I will get the present value of this future, which is located at year 1, added to the present of this future amount located at year 2, and so on. We will do the same for this cash flow diagram. Again, we have C that has to be added when I'm calculating the present value. We'll add it also to the annuity that I will be getting here, but we'll have to mind that this is a deferred annuity. Now here's just as a remark, when I have two arrows of the same amount, I can consider that this is an annuity and apply the equation. But since this amount here is not an annuity, it's located at P0, this means that this is gonna be treated as a single amount and this one as a single amount in the future. Only these four, because they have the same amount, I can use their equation of annuity. So let's look at the solution. With respect to the upper cash flow diagram, when I'm calculating P, we said that this 100 is just added, plus this the second 100, which will be treated at a single value in the future. So P equals F into P knowing FI1, plus this annuity of the value of 150. So P equals A. P equals A into P knowing A, I4, because we have 4 payments of 150. Now again, as we said, this is a deferred annuity because this 150 didn't begin at year 1, it began at year 2. So since it began at year 2, this means that the present of this annuity is located at year 1. So how far is period 1 from P0? 1 year. So this annuity is deferred by 1 year only. So I'll multiply it with P knowing F, 10 and 1. We get the final answer of this part. We do the same for the second cash flow diagram. What do we have? C at P0. We don't have this 100 at year 1, so here plus 0, but we have a C, which is an annuity occurring, but it is occurring at period 2, so this is a deferred annuity. So I apply the same concept. So it is C into P knowing A, I4, and multiplied by P knowing F, 10, 1, because it's deferred by 1 period. So I get the final answer including C, equate this part with this part in order to get the value of C. Exercise number 3, here again, you can see that this is not a complete annuity because we have a missing arrow here. So that's why we will split this part. It will be a deferred annuity. Its present will be here, so it is deferred by 3 years. And this is an ordinary annuity because it's beginning at year 1 and we have 2 payments. So the question here is to calculate what is the amount A. So this is similar to the previous exercise. However, here we have the amount of $20,000 as the amount borrowed, and I want to see what will be the amounts repaid. So by equating this $20,000, we agreed that whatever we're gonna deposit in our bank account is the amount that we're gonna be able to withdraw. Whatever we borrow is the amount that we'll have to repay later, plus the interest. So that's why you will say that this $20,000 is equal to all these amounts. So I will say $20,000 equals to the first annuity, which is the deferred one. We have amount A into P knowing A 10, 5 because we had 5 arrows. And this annuity was deferred by 3 periods, so I multiplied by P knowing F 10, 3. And this is the annuity that only had 2 arrows at year 1 and year 2. So I'm getting the present value because I'm equating this 20,000 at the present. It's already located at the present. So the present of this annuity will be P equals A into P knowing A 10, 2. By equating these sides, you will be able to get the value of A. Let's see exercise 4. Today is your birthday and you decide to start saving for your retirement. You will retire on your 65th birthday and you will need $50,000 per year at the end of each of the following 20 years. So this is the annuity and this is n equals to 20 years. You will make a first deposit 1 year from today. So today is some point in time, which I don't know exactly where in my timeline, but the first deposit will be 1 year later from this period at an account paying 8%. Now, if I make an annual deposit of this amount, will you allow you to reach your goal? Now, what will be your birthday that you're celebrating today? The first step to understand exercises like this is to draw the cash flow diagram so that to see what's happening. So when I draw the cash flow diagram, this is the given. I am present at a period of time today, okay? But I don't know when is today. But I said that I'm gonna make a deposit 1 year from today with the amount of 6,851. So this is today, and these are the annual amounts deposited till my retiree at year 65. And I'm planning that after I retire, I want to make annual withdrawals of $50,000 each year for 20 years, from year 65 till year 85. I want to have 20 withdrawals. So in order to calculate today, so I need to get the number of years from this period to this period. Here I'm gonna introduce a new concept of thinking, which is where to better equate these arrows. We agreed that whatever you're gonna pay is equivalent to what you're gonna get, okay? So you can equate at the future, you can equate at the present, but I don't know where is the present, or you can equate any place in between, okay? Now, to make our calculations easier, if I stop here and make this period of time my reference point or my destination, then when I want to calculate this annuity, the present of this annuity is already located here. So this will not become a deferred annuity. So this will make my calculation easier. And with respect to this part, the future of all these annuities that I'm paying is located here as well. So again, we don't have any deferred annuity. So it's better for us to equate at end of year 65. I'm equating here, equating this side with this side. So if I want to get, if this is my reference point, these arrows with respect to my reference point, what do they represent? They represent the future. So if I want to take these amounts to my reference point, this means that I'm getting their equivalence at the present. Okay, this is the present and this is the future. I want to get the equivalence of these amounts in the present. Okay, so when I'm considering these amounts, I will get its present value. However, when I'm considering this part, I want to get the equivalence of these amounts here. Okay, so as if I'm getting the future of these amounts. Here, I'm getting the present of these amounts because this is my reference point. So we'll get the present of those amounts, the future of those amounts, equate them together to be able to get the value of N. So the answer will look like this. The future at year 65, this means that I'm getting the future of these amounts. F equals A into F knowing A, I, N. This is N, which is unknown. I don't know what's the period from here, this present, till here. It is equal to the present at 65. This means that I'm getting the present of these amounts. So P equals A into P knowing A, I, 20. Here I'm getting, again, here I'm getting the future of this annuity. So F equals A into F knowing A, I, N. Here I'm getting the present of this annuity. So P equals A into P knowing A, I, N. By equating these sides, you will get the value of the factor F knowing A, 8% N. We have so many methods for solution as we proposed before. We can use the equation, we can use the table of interests, you can use interpolation. So here, just as a change, I'm gonna put the equation related to this factor. It will be given for you always in any exam. So the equation, which is equivalent to this factor, equals to the 71.654. You ln both sides, and then you will be able to get the value of n, which is 25 years. Now, if I don't want to use the equation, you can go to the table of interest related to 8%. You will be looking at F knowing A column and start looking at different n's. Okay, let's say for example you will be looking at n equals to 30. Is it close to 71? You will go through the table till you find an answer that is close to your answer. So if you go through the table, you will see that when n equals 25, the value of the factor related to F knowing A 25 is close to 71.6. Okay? Or you can use the method of interpolation. I know that F knowing A 8, n is 71. You can get a value that is greater than this number and a value that is smaller than this number, so that you make sure that the value that you're interpolating is in between. Okay? And using interpolation, you will be able to decide what is n. Okay, so feel free to use the method that you want. If you want to make things more straightforward, just use the equation to get the value of n. Now I got the value of n, but I didn't finish the question. N is the period from now till year 65, which is 25, but I'm interested in knowing P, what birthday am I celebrating today? So just say 65 minus the period of 25, so you are celebrating your 40th birthday. So this was the end of the exercises related to annuity and deferred annuity. I hope that you find it easy to understand. Thank you.